Okay, so the recording has started. This is our lecture and guided practice for Tuesday, July 13th. This is our last full week of of the course. So I'm going to go over what this week's assignments are, what's due this week, and then Monday of next week, your final portfolio is due. Very simple. You can get it done ahead of time and early if you like. And then I'm going to talk about dynamic blocks and stretch, and I just did a video for you about 4 minutes long that I think will probably nail it better than what I can do live, but there we go. So let's take a look and see what we've got for this week. This is our week 6. It's your industry choice number 2. We'll focus on AutoCAD, of course. Some people are doing Revit. And if you'd like to do some Inventor, I'll show you how to do that. But if you can do your solids in AutoCAD, you can do your solids in Inventor. There's just a few extra things you can do in Inventor. But if you want to try those extra things, it's cool. This is your choice, so either select one new industry that was offered last week. There was architecture and civil and mechanical and landscape and interior design and etc. So if you chose, say, architecture last week and you want to try landscape this week, you're welcome to. You just go back and do the one from last week that was there, or you can expand upon last week's work. And most of the folders have something to do that shows how to do more with it based on what you did. But if you want to try something else, that's okay. I'll help you work through it. We do have a playlist. There's a few things in it now. There's the dynamic blocks, which I just put in there from last November. And then there's another one that I did that I think it's a little bit more focused maybe, and it's a lot shorter. So you can watch this one, and I did it specifically for an interior design sample, but you could easily see how it could be used in other ways. And this one is only one of the actions. This was the stretch action. And if you look over here, there's lots of actions that you can take. You can stretch, you can rotate, you can do all sorts of things. You can select different versions of a block. You can mirror blocks. Many, many actions that you can do. They can all be attributed. They can all be extracted. It's a really, really powerful tool. And it's actually what most of the focused tools have built upon. Like, instead of having you do it, they have it all there for you, scripted in. So like Dynascape is an AutoCAD-based drawing tool that just has tons of these things automated inside of it. They took AutoCAD, licensed it, and did all that inside of it. So dynamic blocks are cool. And we'll do a little bit more also in the afternoon class today. We'll do some Revit and how to work with blocks, or what's called families in Revit, and how to even import SketchUp. So we've got a playlist being built. We've got your folders for this week. They're the same as last week. I just added the word "and week 6." So you can go in here, and as an example, here is a part 2 for mechanical that says, take your previous 2D drawings, choose 3 of them, and create 3D models and create a new orthographic view. Now, if you prefer, it doesn't say what to do this in. So you can do it in AutoCAD or Inventor or Fusion. You can do it in whichever one you want. I can help you with that if you want to do a different one. And if you do it in Inventor, you can actually learn how to do a little bit of that finite element analysis with it. So that's how you get along through this week. There are 2 new production and workplace discussion board postings for this week. For production, there we go. Got to get into it. For production, I chose a typical landscape irrigation drawing. And this one's for residential, but commercial looks pretty much the same. And there's a lot of things that you may or may not know what they are. You know, how do irrigation controllers work? What's a backflow preventer? What types of valves are used? What is a main line? What is a branch line? Most of it you can probably figure out. But this is a pretty standard type of drawing. And one of the things that you might notice is, why are there no dimensions? It's like, there's no dimensions on this thing. And you might wonder why that is. There's good reasons for it. So that's your one to do. And again, it's make a video explanation of what you do and do not know about this drawing. And there is a bunch of jargon in here. So there's the week 6 and your workplace skills. Whoops, did I get the wrong one there? Did I do the same one twice? Yeah. Well, I went to the same one twice. Let's come back here. Your workplace skills are about creating a resume. And actually, it's your online portfolio that's included as a link in your resume. This is really sort of the best way. And whether you're gig working or trying to get a job with a company, your portfolio is how people know whether you do good work or not, or not whether you do good work, but whether you do work that they want. And so, as an example, my niece is a landscape architect. She's got quite a nice online portfolio of the work that she's done over the last 10 years. I have an online portfolio for my engineering work. So it's good to have a little online portfolio that you can pull. The question is, how do you do that? And so there are templates and there are things online, and look at some of them, and now you know what's asked for in a job search. See if you can find a portfolio template that sort of will allow you to focus in for your job search. And then find one and then explain why you chose that template. For example, it might be easily modified for a particular job posting, right? You want a portfolio that they can see of your mechanical work or of your just 2D drafting skills or of your architectural work. Or maybe it's something that has to do with some other aspect of your work. Maybe you're a landscape architect, but you're also an artist. So you want to be able to pull the stuff that they're looking for, maybe. Okay? Maybe you choose it because it's super easy to use. It's drag and drop. It's all set up and it's real easy. Or maybe you like it because it's free. Those are all good reasons, and maybe there are other ones. So I'd like you to find a template and quickly explain, why you chose it. So those are the discussions for this week. I have 2 the middle templates listed here. Okay, this first one is what's due at the end of this week. It's your standard one. It looks just like last week's. Lo and behold, it's almost the same, except it says week 6 and it's got the new dates on it. Okay, so that's the only difference. Place image, place image, place image, place image. So it's really sort of, it's very much the same, and you guys did wonderful work last time, so I'm looking forward to seeing more. So that's good. I want to now talk a little bit about your final portfolio template, because it's just a little bit different. So let's take a look at that, and then you'll be set up to use it. First of all, you notice there's no real executive summary. It's just bang, here it is. And you put your name up there. It says how many lab hours this was, because people want to know, did you take 3 years to do this, or did you take a couple of hours? And this is where you'll put a link to your AutoCAD files that have work that showed up in here. So this link to original work are your AutoCAD files that you have images of in here. That's really important. And then on this page, you'll put, just some of your favorite work. Right? This page you don't have to do anything to. It's already set for you. These are the student learning outcomes. Remember, we talked about these at the beginning of class. I left one off because it doesn't lend itself to portfolio work. And that was the one about understanding what a good drawing looks like. Okay, but are you able to demonstrate basic CAD skills, CAD tools for developing orthographic plan views, elevations, and details, and a variety of drawings, including those used in mechanical, civil, landscape, architecture, and interior design. So you want to look at those and be able to show some sort of evidence that you have addressed these learning outcomes. So this is just saying, what slide or slides are you showing it on? So let's say for student learning outcome number 1, which is demonstrate basic CAD skills, you fit them all on one page. Everything you wanted to show fits on one page. That's fine. If you need more than that, you can just duplicate this slide and have it would be on number 4 and number 5. Okay, but I'm not going to do that. So you could say this would be slide 4, 5, and 6. Number of pages 2 or 3 or 4, and so on and so forth. So you'll fill out these once you're done. And it just lets somebody go quickly to the slides that they're interested in. Now here you'll read what the requirement is, and you'll look through all your good work. You've got 6 portfolios worth of work to just pull in images that demonstrate basic AutoCAD skills. And it's up to you to kind of figure out what those are. Okay, but you can imagine that that's copy, move, offset, array, draw line, things like that. And for producing technical drawings, you might also have things like dimension and so on and so forth. So that's really what this class has been about, mostly. But you can put images on here. You can put some text. You want to demonstrate. Give me evidence that you have basic AutoCAD skills for producing technical drawings. You have to think about what that means and give me evidence. Here, this is more focused. It's about orthographic projections, plan views, elevations, details. So any work that you've done where you would want to at least show one orthographic projection, one type of a plan view, one type of an elevation, and one type of a detail. And if you didn't get one of those done, then you would leave it blank, and that's just that. Okay, so this one, and you might have these all on one page, or you might spread them out onto multiple pages. That's up to your own graphic design concepts. And I'm a proponent of some empty space. I believe it's easier for people to focus in when there's some empty space around. As a matter of fact, I taught my kids and all my judo students that, when you cross the street, what do you usually do? You tell people, look for cars. Well, I tell my kids to look for the area between the cars and go there rather than looking for cars. If you look for cars, you're going to get hit by a car. Look for the empty space between the cars and make sure you go there. So I like some empty space in between stuff so that our brains have a chance to relax. But I've seen very good stuff that also packs it all in there. So I'll leave it up to you, but try to make a nice visually pleasing set of presentations for orthographic projections, plan views, elevation views, and details. And then the last one is not so much about what type of view, but mechanical, civil, landscape, architecture, interior design. Now, it could be that you use the same thing here because maybe your elevation views that you have, and you only have one or two, are also used up over here. It is perfectly okay to use the same image or view on multiple slides here. That's perfectly okay. So this one is about just the tool. I got some skills. This one is about how those are used in different types of drawings. And this is how they're used in different disciplines. Okay? And so that becomes your final portfolio. And you have to put your name on each page, right? So there's a little bit of cleaning up, but it could be as short as 6 total pages, or you can add some more. So again, you have some work to do on page 1, but not too much. Just show your favorite stuff. Page 2, you leave alone. Page 3 is just recording where you did what. Page 4, basic skills. Page 5, basic views. Page 6, disciplines. Okay. So there we go. That's your final portfolio submittal. And that's due on Monday, July 19th at 11:59 p.m. You guys have any questions about that before we go on to doing an actual demo today? I'm hoping it's straightforward, but you never know. Okay, so there we go. That's what's up for this week. Again, for today, we went over this week's assignments. We just did the final portfolio. Here's a little video on dynamic block stretch, but I'm going to do one now. And so the one I did before in the video was interior design, but here's a kind of a, it's just a bolt, okay? And bolts come in many lengths, and I'm going to try to do a few fancy things with this bolt. And what this is, and it's just the side view, this is the head of the bolt where you would put your wrench or your Allen tool. I think I set this one up as appropriate for an Allen head, a hex head. And this is the bolt, and these are the threads. So this shows that the threads are a certain length. In this case, the threads are 1.5 inch long, and under the bolt is 3. Okay, and this one is 1/2 inch bolt. There we go. And this is just a representation. You know, it could have a nice chamfer on it. It could have a nice line over here. I could have some nice squiggly lines that show that it's a thread. All sorts of things that I can do, but this will give you the basics of it. So the first thing that we're going to do is make it into a block. To do a dynamic block, the thing has to be a block to begin with. And remember, blocks are just groups of lines that represent a thing that you can compact all together and use over and over and over again. So this is going to be my bolt. Half-inch. And I'm going to say that I'm going to put this in. When I do it, I'm going to use this midpoint. That's normally where you would lock something in. And I'll select my objects. There they are. And in this case, I want to be able to open it up in the block editor to do stuff to it when I'm done. And I'm even going to say that this one, now I can make this dynamic in more directions than one, but I'm just going to show you in one direction. And then if you go watch the video, you'll see other ones, other ways to do it. So there we go. Oh, I can't have. Go. And then it comes up like this, and this is called my block editor. And I've got authoring palettes on. So this little thing shows up over here. And the first thing I want to do is tell it what parameters I'm interested in. Okay, so I'm interested in an overall length. And I'm interested in a threaded length. I'm interested in those two parameters, just things, dimensions that I want to be able to do later on. And you can see there's all sorts of things you can do. Where are things linearly, polar, if it's an array, where it is in an angle, if I want to flip it. These are all parameters. Is it visible or not? There's all sorts of things that I can do, but I'm just going to say I'm interested in distances. And then I can say what actions I want. And oh my gosh, there's so many things you can do, but the easy one is the stretch. And that's the most common one. So that means that I can stretch these as I go. I can say, all right, when I'm in my drawing, I can change this. You know, in a block, it's usually stuck there. But I'll be able to change or stretch this dimension. So I'll stretch my distance 1, and it says, which way do you want to stretch it? Right now, it wants to stretch it to the left, but I'm going to stretch it to the right. Okay, and then it says, what do I want to stretch? So I'm going to pick all of this stuff. It's going to leave the head of the bolt and the left line alone, and then it'll stretch from there. And then it says select the objects. So I'll select those things. Those things. So that one's done. So now let me stretch distance 2. And that one looks like it's going the right way already. And now I'll stretch from this direction. And I'm only going to stretch those 2 items. Let's see what happens here. I'm not sure. I actually haven't done this one before. Yeah, save it. So now when I click on this, I can grab this. Oh, isn't that cool? You can grab it and move it around, and I can even type in the direction. And then when I do this one, oh, that one's not as cool. So I didn't really get that one done right. I should have locked that one on the other end. I probably should have locked that one on the other end. I'm going to get rid of this one and see if I can do that one better. So now let me see if I can. I'm not sure. These things are always of interest. I don't do these that often, so let me do a stretch on distance 2, and I'm going to stretch it this way. And I'll do that. And I'll just stretch those 2 items. Let's see what happens now. That might work better. So now as I stretch that one, then I can stretch that one. That's kind of cool. So that's how you can, out of this one block, you can make many, many, many different ones. Now, I'm going to do one more thing. I'm going to double click on it, go back into the editor, and I'm going to see if I right click and do the properties. Let's see, where's my properties? I think a new thing comes up here. Distance 2. Now I have to figure out, maybe it's in my parameter sets, constraints, parameter. No. Get out of the way. Well, there's. I thought there was. Oh, here it is. Under distance. Distance type. There it is. Value set. So I can set an increment or a list. So I can say that the increment starts at increment of 0.25, and it can be at the minimum 0.25 maybe, and I can go to a max of 2 inches. Now let's see what happens. When I go to here, you can see it only goes by certain increments. So if you have a product that just go, and now I can't go any farther, it'll be at the maximum too. So that's kind of a cool thing. And so, bolts only come in increments of like quarter or half an inch. So you can set increments, and I think you can set it to just be certain values. So let's see over here again. If I take this one, I can come down on my properties, and instead of doing increments, a list. And I don't know where I put that list. Now I don't know. List value. Oh, there it is right there. Distances to add. Maybe 1.000, 1.25, and 4. And now it'll only do those lists. So that's kind of neat stuff. If you have certain things that you want to just show in a certain way, you can do that. So now,
How do you do thread pitch?
um, well, that's normally an attribute because you're calling it out as an attribute, and then you don't normally model that because it's just a feed rate on your thing, and what's really modeled is your thread form, right? You just call out a thread form, and um, a thread form and a pitch, right?
I see.
UNC. But you can, in your attributes, set it up so that this particular one, you double click on it and you tell it what that attribute is. And then when you export that to your machine tool, it knows pick this thread form or whatever. And whether it's a die or whether it's a single point cut, that would be up to the machinist to program that in or to read that off of their defaults. The only time that that's modeled is if you're doing additive manufacturing, like with a 3D printer or something like that. That's really the only time that you really need to model. And even in Inventor, it'll put on a pretty picture of a thread, but it's just a cylindrical hole, and the attributes are in it. Okay, so in that case, I would make an attribute um, and I'm going to make it invisible. Now I can make another block. Um, and now I would put in a 1/2 UNC to be sorry, like a 1/2 13 UNC 2B. And oh, it wanted me to redo all that block editor stuff. So I needed to put in all that block editor stuff again when I did that.
would that be the same too for designating whether or not it's a torque or a hex head or?
Yeah, yeah. Normally, you would put in your attribute what it really is, um, because you don't actually. In most cases, the drawing is just a visualization. When you're talking about fasteners and things like that, you're really just putting them in there as a count because you're not going to make them. You just need a representation of it.
Okay. I was stuck thinking of, back like in the old days when I had to draft the first time where I had to actually draw the stupid bolts.
Yeah, well, you would, but how did you draw them? You drew them like that, right?
Uh, we
Or
we
you
had
would.
really detailed threads and the whole bit.
Why?
I don't know.
Yeah, it's like man, I worked on nuclear power stuff, and we didn't do that. Now we did have to put our minor diameters or our pitch diameters in because we did do overlays. And if our pitch diameters didn't match up, if we, that's how they were looking for whether we had a loose fit or a standard fit or a force fit. They were looking for where these little lines overlaid, and we had to draw within a 64th of an inch. That was our drawing standard for the nuclear industry. But there was no reason to do why. It's like, why are you doing that? Um, but if you needed to, you could, right? You could make a thread block that you put in here that you just stretch for your thing, and it just copies it out. But that would be the array block, the array one, right? You
Oh,
would you would literally draw, and I'm winging it right now, but you would draw that and make a block out of it and do an array of it. How many of them do you want? And what's your pitch, right? You would stretch this and then make your array of it. But I'm not too sure that that's needed.
okay.
Haven't I mean, boy, done mechanical drawings for a long, long time, and we never did that in the field. That's interesting, though. I'll think about that a little bit. They do many, many, many. Like if you go to Fastenal, let's just see if Fastenal has one.
Well, I was thinking more along the lines like if you're in Revit or Inventor and you're trying to do some of those strength analysis, changing the pitch and stuff like
Oh,
that.
it knows it. You just type
Okay.
in what it is,
Okay.
and it factors all that in. It's really cool. Yeah. If you're doing fasteners, you just let it know how it's fastened in your assembly, and and it really does its thing. But that's the other thing is you can go to your um, clamping force book and just apply a clamping force right there. And you know that your fastener is rarely the thing that fails. It's usually around the fastener that fails. And if the fastener is supposed to fail on purpose, then you know what the failure load is, and you just put that clamping force on it. So that's part of the modeling style that you might do. Let's just see if we can get um, well, I'll have to look around in here now for I'm gonna look around and find to see if I can find any actual really real models, products, fasteners, bolts. Are you seeing anywhere where I got? Not looking.
I've got trouble finding things for CAD in general. You know, it was so much easier back in the day. You know, everybody made Visio objects.
Yeah, well, I mean, usually you would go to something like Revit City, Revit Component. Oh, you know who does it is Carlane. These guys have an auto plugin for Fusion and Inventor that I think you can take just about anything out of their catalog and just drag it right in. It's pretty cool. Um, um, yeah. So there we go. So that's kind of cool. Let's see back over here. So that's kind of how I kind of ruined that one. I think I lost the stuff when I made it into a new block. There we go. So if I had done that originally, then I would have had it. But this is kind of cool. It gives you some of the stuff that you can do. Um, and then when you do your extract, you can take that data out of it. So let's come back to the Insert tab and extract some data. And so I'll make a new extraction. I'm just going to throw it on the desktop. Who cares what I call it? I'm going to pick my objects. And what I want is I want to know about the block. That's what I'm interested in. And so over here, if I look at the dynamic block, you can see it's going to tell me distance 1 and distance 2. And it will count up all of the dynamic blocks in here. It says there's one of the 1.5, and it's 3.00901 and a distance 2. And I can give those distances other names. I can call it length under head and thread and all sorts of stuff like that. And then I'll put it in here. Bolt data. And there it is. Isn't that cool? And so now it'll count up all the bolts of different sizes. And of course, we now know that we can export that too, even though we don't really need to. So I think that's really cool stuff. If I wanted to, I could also do the attributes of the threads and stuff like that. Okay, so that's how to do dynamic blocks. If you're working in the interior design or the landscape one and you want to play with the blocks, you can just sort of redo it. And, now you can make one cabinet block and set it up how you wish. And you can make one drawer block, one refrigerator block, and then just put it in there and then sort of stretch it to the dimensions that you want, which I think is really cool. You can lay it out with your lines and then put your blocks in and just kind of like drag the corners of the block to where you want to go. So I think you'll find that it's a lot quicker. And if you've done this, your whole work in your interior design might take you 2 hours where it took you 3 or 4 before. And then you can get it down as you get better at this. That interior design thing that we did is probably in industry about a 30-minute to 1 hour job, to get everything done. Get it on the title block, get it laid out, kind of figured out, and all that kind of stuff. So that's kind of showing us the looking forward through the program how to get effective or efficient at it. Okay, so any other questions about this, about what we've got going this week?
Yeah, I'm not sure I'm clear on what you want as far as what goes on our paper for the drawings for this week. The layout of it.
Okay, let me find this
Running
week.
under mechanical, and I doing the 3D. I figured that out in AutoCAD.
Yep.
Just not sure what I'm supposed to actually make the final presentation look like.
Okay, so it would be your 3D view plus your orthographics.
Okay.
That it came from. And of course you could put that all in one sheet, because on your sheet you can add your isometric view super quickly, right? So it's sort of exactly what you had last week with the 3D view.
But just adding the 3D view up in the other quadrant.
Yep.
Okay.
Yep.
So I had it and I was playing with it and I did it. I converted one of the drawings over and then I hit some button. I'm not even sure what I hit. And suddenly it had 4 different screens open with views and.
Okay. Yeah. You did the multiple views in model space instead.
Yeah. I have no idea how I did it.
Yeah. Let's see. Okay. Let me see if I can figure out how to undo that. MView.
I got pretty quick. I can take the drawings now and convert, my top layer into the 3D model pretty quick.
Okay, view. No, that's not it. Okay, I'm trying to figure out even where that is now. Let's see. Model viewports. There it is right there.
Oh, wow.
There it is. So if you go into view, and some people do this, they need to see the views all at the same time as they're modeling. So this is mostly used in 3D modeling, and many people do this. I personally don't see it this way very well. But you can go to your viewport configuration under view and select how you want to see it. And what it does is it basically takes and then you can set each one of these as you want. Right? You can use your view cube to set each one, and most people will do if they're doing 3D, a front, top, right, and ISO, and they'll just set them.
Okay. Now, would you say it's better to actually redraw the whole thing in 3D mode? Or like what I did was I took my top-down view.
Yeah, that's.
And then I extruded that.
Yeah, that's for the ones that I've assigned, that's the easiest way to do it.
Okay.
You're gonna need that either top view or in some cases the front view becomes the easiest one to use. It kind of depends, right? Which
I couldn't figure out how to turn things into circles doing it that way.
Yeah, no, it's kind of hard sometimes. So but yeah, that's That's the essence of it. And even if you do it in Inventor, it always starts with some flat view of the shape, and then you give it its depth or its height. And you can, in Inventor, it's real easy to apply taper and draft and all sorts of other things. You can do it in AutoCAD too. Like I said, if you can do it in AutoCAD, Inventor and Fusion are just like a 1 day transfer of capabilities, and then you can do it.
Okay. And then I'm still not clear. What is the difference between press pull and the
Okay, so extrude.
Extrude,
Okay.
yeah.
So
Because that gives me this weird wireframe thing that just confused the crap out of me.
yeah, so extrude does just that. And if you pull lines, it gives you a surface mesh. And so
I couldn't figure out what
press
to do.
pull gives you a solid. So let me
Okay.
give you an example though. And this is really for the modeling class, but I'll give an example here. And certain things work with extrude and certain things don't. So I'm gonna.
The extrude just added so many more lines. I couldn't figure out what I was supposed to do.
So if I extrude these lines, it's gonna actually do just that. It's like a surface. That's it.
Okay.
There's nothing actually to it. It's just the definition of a surface. Whereas press pull, let me get inside of it.
There's the solid surface. Okay.
Press pull, it's a solid thing. Okay, now if you make this something called a region, and I'm going to show that to you in conceptual now, you can see that made that into a surface already, a region. And then if you extrude the region, it has some height.
Okay.
Now, the nice thing about that is that you, in the properties, you can give it taper and some other things. You can give it like a 5-degree taper angle. So that's where extrude becomes a slightly more powerful tool than press pull. Because as it's a solid, I can do a few more things to it when I extrude it than when I press pull it. And so the differences are kind of esoteric.
But like extrude's going to give you better control over your tiny fillets then.
Yeah, things like that. And
Okay.
and it lets you have a little bit more control over what you extrude, and you can do some more stuff. But they've actually, press pull is like, they didn't put it in until 2016. And so we used to have to make regions and do this and do that. It was like a lot.
Yeah, because I did like the floating arm, and then I played around with the extrude for probably an hour and a half before I gave up, and then I did the entire thing in press pull in 5 minutes.
Yeah, press pull is, unless you know about that region command.
Okay.
There are some reasons that start getting esoteric about doing regions, and when you extrude them, it keeps some data and doesn't keep other data. But you got to be really seriously into specific needs to care about that at all. It's like, not at all.
Then I'm thinking you're using a different product anyway.
Yeah, by that time. But those products are all built on on the basics of this. Um, so there we go. And so you can do, what's cool is you can do, let's see if I can get this thing to work. These are cool things you can do too. Slicing and thickening, and the fillet doesn't work that great, but I can taper faces, and so there are really cool things you can do. I'm going to, I think now that I can do something called thicken. No, that's a region 2. Well, let me get back to this and just try and see. I'm just going to see if I can. I'm not very good with surfaces at all. Some people are much better, but I think that I can thicken those. Thicken that surface 0.25. And so this is how, if you do have a surface model, let's say you brought in a SketchUp model and it's really a bunch of surfaces and you want to create real walls or real thickness to it, you can do that. And so see how I just made it into a real, so these things can be used, but it can be a little bit hard. Now I want to show another cool thing. Another thing just for fun, because I'm having fun. Love doing this stuff. Now I'm going to press pull that thing. And I'm going to do something called the shell command. And I'll remove this top face. And I'll shell it 0.375. Isn't that cool? So the shell command is a really nice way to quickly make, a box without a top, or a pipe of a certain wall thickness, or things like that. So that's really a cool thing that you can do too. So there we go. All right, that's it. Any other cool questions?
I have a non-class question for you when we're done.
Okay, then I'll go ahead and stop sharing and turn off the recording.